You are immortal. This isn't a metaphor. The atoms that make up your body, the carbon, the oxygen, the iron, are eternal. They were forged in the hearts of stars that died billions of years ago, and they will outlive you. They will outlive this planet. They will outlive the sun itself, and they are destined to spend an eternity alone in a cold, dark, and perfectly empty void. This isn't a guess. This isn't a theory. This is the most profound and unchangeable law of our universe. It is our final destiny. Welcome to Starlight Explained. The story of our universe is the story of a brilliant, fleeting moment of light, followed by an eternity of darkness. This is the story of the heat, death. I need you to stay with me on this journey, because what we are about to see is not an end, it is a transformation. And by the end of this video, I will show you why this cold, terrifying, and lonely future makes your life, right now, the single most important and beautiful thing that will ever happen in the history of time. Our journey begins now. We live in the Stelliferous Era, the age of stars. For the past 13.8 billion years, the cosmos has been a vibrant, creative, and chaotic place. Gravity has pulled vast clouds of hydrogen gas together, igniting them into trillions of stars. These stars, in turn, are the great forges of the cosmos. They are element factories, taking simple atoms and crushing them into the carbon in your body, the oxygen you are breathing, and the iron in your blood. From the brilliant, short-lived blue giants that burn 1,000 times brighter than our sun and die in spectacular supernovae, to the calm, steady yellow dwarfs like our own, and the tiny, dim red dwarfs that will outlive them all. This glorious age of light, this now, feels permanent. It feels eternal. But in the grand scheme of the cosmos, it is nothing but a brief, brilliant springtime. It is a fleeting flicker of light in an ocean of darkness. And it is already coming to an end. In the most ancient galaxies, star formation has already ground to a halt. Our own Milky Way is expected to collide with Andromeda in 4.5 billion years, an event that will likely use up much of our remaining gas in one last spectacular burst of star birth. After that, our joined galaxy, Milkomeda, will slowly fade. The last star in our universe will likely be born in about 1 trillion years. Our first stop on this journey is 1 trillion years from now. By this point, the universe's great burst of creation is over. All the free-floating gas has been used up or scattered by the relentless expansion of space. No new stars will ever be born again. The only lights left in the sky will be the last red dwarf stars. These are the tiniest, most miserly stars, sipping their hydrogen fuel so slowly they can last for 1 trillion years, but even their time is finite. One by one, the last dim embers of the cosmos will flicker and go out. The universe will plunge into a profound, irreversible darkness. The Stelliferous Era is over. Welcome to the Degenerate Era, the age of stellar corpses. This is a universe of ghosts. It is a vast, cold, and expanding graveyard, populated only by the silent, dead remnants of the stars that once shone. The cosmos is now a dark sea, filled with white dwarfs. The cold, crystallized, diamond-like cores of dead stars like our sun. Initially, they will be immensely hot, but with no fuel to burn, they will spend quadrillions of years just cooling off, eventually becoming black dwarfs, colossal, planet-sized diamonds floating in the eternal dark. Neutron stars. The ultra-dense, city-sized remnants of massive supernovae. We see young ones as pulsars, lighthouse beams of radiation spinning hundreds of times a second. But over eons, this spin will die, and they will become perfectly smooth, perfectly silent, dead spheres. And the great gravitational monsters, black holes. For a time, this age will be punctuated by rare, accidental violence. The universe's accelerating expansion, driven by dark energy, is pulling the galaxies apart, but within the gravitationally bound clusters, things are getting closer. Orbits will decay. Two white dwarfs, after spiraling for eons, might collide and erupt in one final useless Type 1, a supernova, a brief, lonely flash of light in a universe that has forgotten what light is. Two neutron stars might merge, sending out a final burst of gamma rays and gravitational waves. But these will be the final fireworks. The universe's expansion is pulling everything else apart. These encounters will become rarer and rarer, until the distance between these stellar ghosts is so vast, they will effectively be alone, forever in the dark. Now we leap forward in time so far, the numbers lose all meaning. We are at 10 to the 40 years, a 1 followed by 40 zeros. We have entered an age so alien, it defies imagination. By this point, even the immortal remnants of the Degenerate Era have died. A process known as proton decay is theorized to have taken hold. This is a profound prediction from our grand unification theories, which suggest that at high enough energies, the fundamental forces of nature merge. A consequence of this is that the proton, the very particle that builds the nucleus of every atom, is not truly stable. Over a timescale of at least 10 to the 34th power years, protons are expected to decay, to simply dissolve into a puff of lighter particles, like positrons and photons. This is the ultimate death of matter. The great, crystallized white dwarfs will evaporate, atom by atom. The hyperdense neutron stars will dissolve all matter as we know it. The last, cold, dead reminders of a living universe will have been scoured from existence. Almost nothing. The only things left in the universe are the black holes. They are the last kings of the cosmos, the last bastions of structure, order, and gravity, looming in the infinite, empty dark. They have patiently spent this era swallowing any stray matter, growing in size and power. They are the final victors. But even they are not immortal, and their death is the most mind-bending, beautiful, and terrifying fact in all of physics. In the 1970s, Stephen Hawking discovered that black holes are not truly black, they evaporate. According to quantum mechanics, the empty vacuum of space is actually a roiling, chaotic foam of virtual particles that pop into and out of existence in pairs. A particle and an antiparticle. They are born and then immediately annihilate each other. But if this happens right at the edge of a black hole's event horizon, something profound can occur. One particle can fall in while its partner escapes. The particle that fell in has negative energy, which it subtracts from the black hole's mass. The particle that escapes flies off into space as a real, detectable particle. This is Hawking radiation. It is the slowest leak in the universe. A black hole the mass of our sun would take 10 to the 67 years to evaporate. The last supermassive black holes, with the mass of entire galaxies, will take a Google years. That is a 1 followed by 100 zeros. A number so large that if you tried to write it down, the ink in your pen would outweigh the entire observable universe. But it is not infinite. It will happen, one by one, over eons that make the age of the universe seem like a single heartbeat. The last great monsters, the final holdouts of structure, will radiate away their mass. As they shrink, the process accelerates, until the very last house-sized black hole radiates away its final ounce of mass and vanishes in a tiny, final, fleeting flash of light. We have arrived, the end of the journey, the final reveal I promised you. The last black hole is gone. The universe is now an infinite, cold, dark, and perfectly uniform void. It is filled with nothing but a diffuse, freezing cold mist of stray photons and elementary particles, separated by such vast distances they will never, ever interact again. Nothing happens, and nothing can ever happen again. The universe has reached a state of maximum entropy. This is the heat, death. It is the ultimate silence. But here is the final, staggering reveal. In this state of perfect, uniform stillness, something profound has happened. The very concept of time has ceased to exist. Time, after all, is just a measure of change. It's the arrow of time that points from order to disorder, as dictated by the second law of thermodynamics. But when the universe is in a state of perfect disorder, or entropy, there is no before and after. There is no change. The arrow of time breaks. The universe is not just dead, it is frozen in an eternal, timeless nothing. It's a chilling, almost unimaginable end. How does confronting this ultimate eternal silence make you feel? Let me know your thoughts in the comments with #eternity. So, what does that mean for us? For you, if the universe is destined for an eternity of meaninglessness, what is the point of any of it? What is the point of this? That is the reveal. The meaning of the universe is not at the end. The meaning was the journey. It was the 13.8 billion years of light and complexity. It was the stars, it was the planets, it was the life, it was the brief, improbable, and beautiful flicker of consciousness that allowed the universe just once to look back and be aware of itself. Our existence is not defined by its permanence, but by its extraordinary improbability. We are not a part of the story. We are the story. The universe's final, cold fate doesn't make our lives meaningless. It makes them the only meaning the cosmos will ever know.